Is this? It's a trash can. Oh, not that. It's been what? Ben Eater, my idol, making logic gates from transistors. What is that circuit? Let me see if we have that. Oh, this one. If you push the button, LED turn off, release, turn on, push the button, turn off, release the button, turn on. What is this circuit? Well, according to my idol, it is inverter using transistor. If you push the button, it will turn off. Release the button, turn off. Let's see the circuit. That is the circuit. We have here the power supply or the source, 12 volts. And then the resistor here, for base resistor. And then we have a resistor here. And then the LED here. Seems that the LED is shorting this transistor. But if you analyze the circuit, the current flows here. From here, and stops here because the switch is open. So another here goes here, and since the switch is open, transistor is open. The current flows here. So that's why the LED is turned on. What is the value of the resistor here? Why we need resistor here? In order not to destroy the LED. And also a resistor here in order not to damage the transistor from this source. So I compute. If we only want to know how to make the LED turn on, so you just follow the circuit here. So the voltage here from here to here is 12 volts since they are connected in parallel. Also the voltage here to here is 12 volts. Calculating the value of resistor, since this is a collector, there is a collector current here, and the collector current here goes here, and then we know from the data sheet that the current of the LED is 20 milliamps in the data sheet, and the voltage for the LED to turn on is 2.5 volts. We already get the current and the voltage for here, so we just need the resistor value, and I compute that using the Maxwell mesh method. Voltage supply minus the voltage drop here minus voltage drop here, we have this one, 9.9 volts. Then the resistor from Ohm's law, my favorite magician, Ohm's law. Resistor is equal to voltage over current. That will give you, since the voltage here is 9.9, 12 volts minus the voltage drop across this voltage in the diode. So we have now 9.9, and the current is the same here. The current flowing here is the same here. Since they're in series, is now when we divide that, we've got 396 ohms. So we need 396 ohms to in series with the diode or LED. But I use 500 ohm. Now here we need to calculate the resistor here, voltage drop here, current flowing here, voltage drop here, voltage drop across the transistor is given. That is 0.7 volts. That is the given voltage drop across the transistor from the manufacturing company of this device. So 12 volts minus the voltage drop here minus voltage drop here, we have a voltage here 11.3 volts. So from Ohm's law again, voltage is equal to current times the resistance. So resistance 1 is equal to 11.3 from calculated here divided by Y 10 milliampere. 10 milliampere is from the data sheet here. See, in order for the saturation voltage collector to emitter, we have this 10 milliampere, well, current base of 10 milliampere and the collector current of 100 milliampere, making the voltage drop across the collector emitter 0.25 volts. So this one is 10 milliampere, it becomes 1.13 kilo ohms or 1.2 kilo ohms or 1.5 kilo ohms. Now we have the resistor here, the current flows here. When we push the button, the current goes here and also goes here. Why the current don't flow here? Because the voltage drop here is from the data sheet. It's 2.1 volts. But from the data sheet of the transistor operating saturation, voltage drop here is just 0.25. So the current flows here instead here, this one, because the current is so lazy. There's a drop here, much better to flow here, shortcut. So this one flows here and this one flows here, operating transistor in saturation, and that's it. We have now an inverter. Truth table, if there's no input, still the light goes on. We push the button, becomes 0 or the lights turn off. The symbol for inverter here. So this one is an inverter, huh? Very nice invention. Nice. Just like this. Push button on, off, on, off, on, off. No pushing or no signal, 0. But in pushing 1, on. There is no signal, 0. The inverter. Nice. Thank you.